Hello, hello. Welcome to Swarm Foundation's event. It's about storage incentives, the missing piece to make blockchains complete. And the first one on stage, I would like to welcome Gregor Žavcer, who's going to share with you ecosystem updates and more, I'm sure. Welcome.
Hello. Hi, everybody. It's great to be here. So it's actually my first time here at Seabase, and I'm mega happy that we are here, and it feels like home, like kind of that instant feeling. So also, thank you everybody here to come to hear what we are up to, thank you. Special thanks to Ligi and Seabase crew also for making this happen. So we have a lot of things to cover today. I'm going to try to just kind of fly through it, but happy to discuss it later more in detail. Now, what I need to do, it's like this. Okay. So. What I'm going to talk about today, basically just a quick refresher of our long-term goals, highlights of the current activities, and then we have the special announcement about our big network upgrade that essentially started yesterday. We are continuing then with a little bit of insights into how we want to tackle ecosystem development. Okay, we got dark. It's okay. So we're back. Good. So let's just jump in. So Swarm has been started in ancient, let's say, blockchain history with a goal to essentially and eventually become this public utility, the decentralized data global layer. And we are always have been true and still are staying true to this mission. As part, at the same time, Swarm has always been a decentralized project. So in that sense, part of these long-term goals, it's also, yes, to eventually become a DAO. Now, there's, especially these days, there's a lot of talks about the DAO, and in a way, we do see this as a longer process. It's going to take time, and one could maybe even say like, sort of like next generation DAO. So we have here some really big experts on the DAO topics, and those guys like Aaron there could tell a lot more about that. And the last thing which is kind of really important is our long-term goal is positive social impact. And I know this sounds like very corporate, but if we go like, if we dig into it, if we go to the base, to the ground, to the roots, what does this mean? So first, the question is, how can we know what is positive social impact? And the only way for Swarm, in a way, to figure out, to see this as a metric is essentially to observe its ecosystem. It's like what kind of ecosystem emerges on top of Swarm is basically the reflection of this positive social impact. And moreover, it's also, this has in it a lot of other, I would say, like deep truths in the sense that, first, when we think about it, like as technology developers, so if it would be just about, let's say, research and cracking the technical problem, then it would be, in a way, enough to be just, yeah, a research institute or working at a university, putting out papers. If it would be just about, you know, us being engineers and just kind of also making this happen, that it computes at the end, that's one way to look at it. But, you know, looking from a live perspective, it's, I would say, also the team and everybody and the ecosystem, we've got together because also down the road, 10 years down the road, we want to see good things happen. We want to be proud that we made, like, maybe are leaving this place a little bit better than it was when we came in. So essentially, it's like, what does this then also mean? It means that it's not just about science, it's not just about engineering, but the social aspect, the ethics part, is also quite important. And this is this is basically already a little bit of pre-announcement of what I'm going to talk about when we go to the ecosystem. So positive social impact, it's a lot, very, very important. Now highlights, what have we been up to? So right now, yesterday started phase 1 of the big network upgrade. It's for Swarm, it's been a long road. Our research team is doing an amazing job, and in a way, also this long journey, I would say that persistence is our team in many meanings. You know, it's not just about persistence of the data, but also how our team is persistent at cracking the problem. The other part, coming also with a big network upgrade, is improving the economic self-sustainability of the network. In other words, making Swarm unstoppable. And then we just released and are pushing updates for a desktop app. A little bit more about that also later. And there's what I'm also going to talk about later. It's thinking exactly about this, how to start the ecosystem, how to enable the ecosystem, how can Swarm empower digital freedom by making data unstoppable? Because it's not just about looking, okay, you know, we do the grants program. No, it's more. It's not just about, okay, we do some voting and things like that, copying and what others are doing. It's also the context that it's important. So network upgrade, and this is basically the special announcement. This is you guys here are the first one hearing about this. We haven't published yet the info. Well, you know, it's happening. It's happening. It started yesterday, and we are quite excited about it. And there's yeah, the heart is beating faster, so to speak. So a big chunk of this big network upgrade is the new storage incentives. So it's in a way the first. Dani will speak more about them, but it's been a very hard problem to crack. And I think Victor the other day mentioned that he estimates that there were something like 20 iterations on it to really make it happen. So part of the network upgrade is also the network calibration. So there's going to be price adjustment. Following that, it's going to also be decentralized price oracle. So decentralized price oracle, it's kind of, it makes the network unstoppable in that sense. It's like, it's not, it distinguishes Swarm from other projects. It's not just a marketplace for data. It's something that basically, like an organism, can self-regulate itself in terms of demand and for the storage. And of course, there's going to be network improvements. Now, this sounds all good, but how is this going to happen? So, like mentioned, yesterday we started with phase 1 on mainnet. This has been like, the nodes are being upgraded B1.8. In case anybody has been looking, that we have like this indicator from a community-driven project, Swarm Scan, on our website that shows how many nodes are operating in the network, and the node count has been going down because Swarm Scan is still updating also on the new network. It's a breaking change, so I invite here everybody to update your B nodes. Following that is in the first week of October, we are planning to release phase 2 onto testnet. This is here the price adjustments happen here. Basically, the distribution to node operators happens. This Dani will go more into it. Followed by phase 3, which is the price oracle. So this, as we see, it's really, we are in the gist of it. And if anybody is wondering, what are these like MEC at the end? MEC stands for monthly ecosystem call. So on the monthly ecosystem call, which is every last Thursday, there will be concrete updates when these changes are happening. So if you want to be in the know, in the loop, join those calls. And we see how it also then progresses. It's each phase is basically taking Swarm to the next level, and it's going to be quite exciting. the details about the phases, we are going to communicate them extensively in the coming weeks on the events that we have, on our calls, on our blogs. So, and also we can speak about this after the call, after the talk. Now, so this going from the big network upgrade, the gateway between the network and the ecosystem is the desktop app. And I would say here, it's like gateways are so 2021. It's, in a way, I would even be here like a little bit provocative and say like, those who are pushing for gateways are not really pushing for full decentralization. So here, something that we also didn't speak out loud, as Swarm, we don't really plan to offer any gateways because it's so easy to install your own node. And that's what decentralization is about. And here we have also special flyers here at the event. And these have like also a code, a gift code behind it. Take them. It helps you not just to easily upgrade your node by preloading some funds to it. So here are the flyers. Please do take them. Okay, let's go now to the ecosystem. So I said before, positive social impact. And in a way, there's even like, if we get a little bit philosophical, so if the ecosystem reflects our positive social impact, then in a way, Swarm without ecosystem is meaningless. That's why it's not like the one and the other part, it's, well, a Swarm. So, so in that sense, we've been also in the background, we've been doing quite a lot of research how to create a value-aligned ecosystem, how to think about values, not just about code in that sense when we speak about the ecosystem, and also how Swarm can actually act sort of as this narrow waist of fair data economy. So that's a lot to unpack. So narrow waist being think of internet protocol is the narrow waist. It connects the devices and it enables this diverse ecosystem that we call the internet. And in a way, here Swarm also, it's down the road, it's just this tiny part that enables massive innovation on top and connects also various data sources below. So that's what we are researching, and there's also going to be a release called Ecosystem Toolkit. We plan to do this end of the year, and looking to feedback. So this is a little bit just intro into the ecosystem. Now, one other thing that we are looking into is calling unbundling the app. And what does this mean? So when you think about it, when we use our computers, our PCs, or however we call notebooks, the interaction and the way how we deal with data is completely different in a way that what we do on the web or on the mobile. Now, the mobile apps or the web convinced us that, an app has everything. An app needs to be the UI, the algorithms, it needs to be the data. But the apps on the computer, it's I can just have I can start a music production software. I make music, I save the music files or MP3s on my disk, and it's done deal. It's not in the app. And then I open a video production software, and I just load those MP3s into there, or the WAV files or whatever. And I save the video files back on my disk. So on the computer, when we use it, the app is unbundled. Now, when I go to my mobile phone, I don't see the data. And this is like the poison for interoperability in that sense. It's it's like the kryptonite for the digital natives. So, and Swarm basically enables that we change this. And this is part of the innovations that we want to build on top of it. So it's I'm trying to not stand on the cable. So by doing this, I would argue that we enable the way to privacy, we enable the way to data interoperability, and we enable the way to data sovereignty. And this is the alternative to what we see today unfolding. So to do that, it's basically this what I said with the ecosystem before. We are supporting development of what we call fair data protocol. It's outside of immediate scope of Swarm, but in a way it's our moral responsibility to support initiatives that go against walled gardens, that promote data interoperability and data sovereignty. The other project that we support is, and are very active in it, it's FairDrive. FairDrive here is meant to work, basically is the UI to the Fair Data Protocol. What it does, it's kind of, imagine, if I go back to this analogy of using the computer. So one of the most probably underrated apps on the computer is the File Explorer or Finder. It's like nobody ever said, I chose Mac because the Finder kicks ass compared to the File Explorer. Nobody said that. But when you think about it, this is not an endorsement for Mac or anything, just to be clear. The concept of it, what this File Explorer does for the user, it connects all the apps on the computer. It's basically the window into the file system. So what we can here see, like with using Fair Data Protocol, connecting all the data sources, we can help the users to basically to use their data meaningfully, to have like data created in one dApp and be used in the other, so taking things further. And this is exactly what we try to kind of do and illustrate with what we call the startup recipe. So what's the startup recipe? It's very simple. There's so much code already around it. You know, it's about decentralizing the web. So if one goes to GitHub, probably you can find like almost everything there. And it's, let's decentralize it. The very easy way, fork it, connect it to Fair Data Protocol, upload it to Swarm, link it to ENS, and through the File Explorer, grow the adoption of your dApp. So it's like, you know, when you install a PDF reader on your computer, all PDFs get like this nice icon of the PDF program, and you double click it and that PDF reader opens. Imagine that for a dApp developer. And we can have here like emergence of a new kind of a developer. It's like, Elad, I see just joined, and this, I'm taking it from here, 2 years ago, or something like that, he coined the weekend developer term. So, and this basically, this startup recipe enables just this. It enables a single developer to actually do start a very powerful project in a very easy and very fast pace. Now here, I'm actually also taking another phrase from Elad when we spoke the last time. And it's this recipe right now, that's sort of like a disclaimer. It's kind of like alpha info. It's a single player mode. So it's about the apps. When we think about PDF reader and things like that, it's not yet about collaboration. That's going to be the next step. And here we have just an easy example. This is we are going to publish also that info very quickly. So we actually did like POCs on this, taking one package, open source package, connecting it to FDB storage, uploading it to Swarm, and you know, voila, you have like a fully fledged, in this case, slideshow app. And this app, once on mainnet, can be featured in FairDrive's app store. So, and Dracula, for example, is a markdown editor. We can imagine that on the web, we can start very easily to work like, I write a markdown note in Dracula, I save it to FairDrive, I open slides, I generate slides from that markdown node, I import photos from Fairphoto, and maybe when I do all this, you know, I even could maybe generate an NFT out of it. That wouldn't make so much sense, but okay. Just to give an example how data can play, and all this in the private space. So that's basically about it. Now, what's in the store for Swarm going ahead? We keep on developing. It's like, that's like I said, persistence is our theme. So we are not stopping. There's going to be more features, stronger network, making it bug squashing, you know, so that eventually everything just works. Growing the ecosystem, one of the big topics that we see is supporting free press and essentially permissionless publishing, giving publishers a voice. We are looking into how Swarm can be used as a store for NFT metadata, more dApps, and also very exciting part we call internally, it's not a project, it's going to be like probably continuous activity, we call it the great data upload. So how to bring meaningful, positive data, social good data onto Swarm. Now in terms of R&D, big topics also, among others, these are just highlights, are decentralized service networks. So those of you who know Swarm for very long, you know that there was already a paper published, I think in 2017, or was it in 2018, called Swap, Swear and Swindle. So those things are still in the store. We are looking into fair data economy, how basically individuals can be empowered through privacy, data interoperability, data sovereignty. So these are like our R&D activities. There's going to be more decentralization in the ecosystem, scaling in the coming months through creating purpose-driven DAOs, either to manage grants, to manage various aspects, like the VEM community, and bigger events. So We Are Millions Hackathon is going to happen again next year, March 1st. And next year we're also bringing back the Swarm Summit. It's been too long, and yeah. So hope very much to see you there. And basically that's it from my side. Do connect with me after the talks or at these places or online. And now I would ask for our next presenter, for Dani, to come on stage and yeah, take it deeper into the Swarm territory.
Hello, everyone. This talk is going to be about storage incentives on Swarm, and I'm going to give a brief introductory overview of how these things work, and we'll also highlight how the most recent update affected and where we are along the roadmap. So why do we need decentralized storage at all? So if there are no centralized pressure points, then it means that we have true censorship resistance, because there's basically no single point to attack. There's nobody to ask to take some information down or to change it or something like that. Very importantly, we need unstoppable front ends for unstoppable smart contracts. So currently smart contracts on Ethereum are indeed unstoppable. However, decentralized applications are anything but, because usually people interact with smart contracts through front ends, through so-called Web3 applications. And typically these are hosted in a Web2 fashion by standard web hosting, and they can be taken down, and they are actually taken down. So the most recent example is, of course, Tornado Cash, which, the smart contract is there, but the front end that everybody used is not there anymore. And since it's being sanctioned, nobody dares to, or at least very few people dare to run front ends, and basically there's no way to access it in a user-friendly fashion, and very few people have the tools, the skills, and the patience to interact with the smart contract directly. So in order to solve these problems, in order for distributed applications to become truly unstoppable, it's very important that the front end itself is hosted in a decentralized fashion in such a way that it cannot be taken down. And decentralization also provides a bulwark against what I call a Library of Alexandria fire event, when a lot of important information is lost or damaged forever. So humanity currently has, of course, a treasure trove of information, and some data are very, very important, and it would have a devastating impact if some of that data were lost. So imagine a world without Wikipedia, for example. And currently Wikipedia is a semi-centralized project. You know, it can, Wikipedia Foundation can go bankrupt or can be pressured into into doing something, but also there are natural disasters. So, you know, some data centers might go offline because of floods or fires or something like that. And this would leave us without a very important resource. And in order to be resilient against that, we also need to host important information in a decentralized way. So incentives are super important. The first decentralized data storage network, GNUtella, has been around for decades now, but it didn't come with an incentive system. And as a consequence of that, it simply doesn't work. It's very slow. Running a node is, at least when there was interest in it, it was very it was a large burden on the node operator because there was a lot of spurious data uploads. And all of that because there was no incentive to participate, to provide more storage beyond you know, altruism. And also there was no incentive to somehow limit uploads, to really you know, distinguish between important and unimportant data, and to upload only what's important. So people were just uploading a lot of stuff, including completely random noise, just in order to, you know, stress the network, to test things, because there was no penalty attached to it. So what we would like to see by putting decentralized storage and storage incentives together, that the storage resources get allocated more efficiently. So those people who can bring more storage to the network will actually have an incentive to do so. And people who want to upload data will also have to decide what is and what isn't important. So the end goal is to store as much relevant content as possible and to provide, while providing adequate redundancy, so that nodes going offline won't actually take the content offline. So we want to incentivize both the usage and the provision of storage resources in an efficient manner, so that the supply and the demand of storage match each other. So, put it bluntly, uploaders should pay and storers should earn. And now I would like to say that before the upgrade, what actually happened, that uploaders paid a very minimal fee just as a spam protection measure, and storers didn't earn anything at all. And now this is going to change, because we're going to start redistributing the storage payments, and first through a network recalibration, and later on through a automated price oracle, the prices that the uploaders pay and the storers earn will be set to something realistic that keeps the supply and the demand in balance. So how are the incentives implemented? So it's a set of smart contracts on an EVM-compatible blockchain. In particular, we're currently using Gnosis chain, or formerly known as XDAI. The reason we don't use the Ethereum mainnet anymore is because transaction costs went way up. Now they're actually back into usable territory, but still, whenever there's a big NFT sale or something like that, the price they price out everything else, or some DeFi craze. So we were counting on Ethereum scaling, but it didn't yet happen, although today they will finally merge the consensus layer, which is a proof of stake network, with the execution layer. And that will open up the possibility of scaling Ethereum through sharding. So maybe in the future we will move back to layer 1, or maybe we will find some other layer 2 solution. So all I want to stress is that being on Gnosis chain is a temporary stopgap measure, and we are by no means married to it. So we use an ERC20 token for payments. So we have our bus token, which is used both for charging uploaders and for rewarding storers. And all it is played out in a shelling game where a number of participants need to agree on who is entitled to receive the rewards. Because obviously not all the information about who stores what can be on the blockchain, because it's just too much information and it would be too expensive. So instead of that, we use the common technique of using a shelling game to link the off-chain reality to the on-chain state. So here I would like to give a brief introduction into how Swarm works under the hood, so that you can better understand how the incentives work. So all data is stored in small 4-kilobyte chunks, which are redundantly distributed among the nodes, meaning that not every node stores all information, but all information is stored by several nodes. So the addresses of nodes and the addresses of chunks, they come from the same address space. It's called the Kademlia distributed hash table. It's so it's the topology into which Swarm nodes organize themselves. And the content is divided up between the nodes based on the first few bits of its address. So it's the content's address that decides eventually which nodes will store which piece of data. And the nodes that share the same data, they're called the neighborhood. And basically it is, so the incentive system works in such a way, the redistribution of storage fees, that first a randomized process selects a neighborhood, and then within that neighborhood, because everybody is supposed to store the same content, they perform a calculation for which the content is used as an input, and then they do a commitment to the result of this calculation, and then every node who wishes to participate in the redistribution reveals the result of their calculation, and if it's all the same, then one of them will win, and if it's not all the same, then on a probabilistic basis, but essentially with the largest probability, the ones who have more stake have a greater probability of winning, and those who disagree with them will get their stake, well, first frozen and then slashed. So how do uploaders pay? So they pay in batches because you cannot pay for every chunk on chain. That would be, again, prohibitively expensive. So payment is done in batches. So you pay for a batch of chunks on chain. Thereby, you register a public key and an identity, and then you use the corresponding private key to sign each chunk that you upload. And we call this signature with the ID a postage stamp because of the analogy. So you are providing evidence of on-chain payment off-chain by affixing these postage stamps to individual chunks. And then each node, when they encounter a chunk with a postage stamp, they can decide whether it has been paid for or not, and whether or not that payment has already expired. So these batch balances, they're regularly debited by rent until this balance goes to zero, at which point the batch expires. And the content that is only postage stamped from that batch is going to be garbage collected from Swarm. So there needs to be a regular payment for keeping content available on Swarm. And the pricing is it's proportional to the volume and the duration of storing the data. So the longer you want to store it, the more you have to pay, and the more you want to store, the more you have to pay. And this rent, which tells you the price for a number of chunks for a number of days, this rent is adjusted in such a way that if there's an overcapacity, so the node storage is not used to its full, then the rent is going to go down, which will incentivize more uploads, but also might cause some of the nodes to leave. And this way it brings back the balance. But if there's a shortage of storage capacity, then the rent goes up, which incentivizes to upload less and might also incentivize new nodes to join the network and provide more storage. So this way, a equilibrium of supply and demand is maintained. I already talked about the redistribution. So a few points to mention is that nodes need to put down a non-withdrawable stake in order to participate. This is to incentivize long-term participation so that nodes don't just show up when the rent is high and then withdraw. So once you put down a stake, you cannot withdraw it, and you should use it. And it takes time to earn it back. But if you misbehave, then that stake can be lost. So it provides additional incentives to play nicely. So these redistribution rounds, they happen regularly in a following way. So first, an on-chain random oracle picks a winning neighborhood with a uniform probability. So each neighborhood has a uniform, the same probability of winning. But then nodes in that neighborhood commit and then reveal a deterministic random sample of the neighborhood content. So there's an algorithm by which they sample the content that they store. And if they're really storing the same content, they should arrive at the same random sample. Then the correct sample hash is selected with a probability that is proportional to the stake. So the more stake vouch for the same content, the more likely it is that that content will be accepted as the truth, as the reality. And nodes that are not revealing this sample hash have their stakes slashed, or actually in the beginning it will be only freezing, because there might be bugs and we don't want people to lose their stakes because of mistakes that we make. So initially it will be stake freeze, but later it will be slashing. And from the rest who revealed the same content sample that the selected truth oracle revealed, again with the probability proportional to stakes, the winning node is chosen. So this process is actually very similar to proof of stake validation on blockchains. So the more stake you have as a well-behaved node, the more you contribute to keeping the rest in line, to the security of the network. And of course, the higher are the chances of you being selected as the winner. So the analogy is fairly straightforward. The winner pays the gas costs of slashing and transferring the payout. So because the winner already has an incentive to claim their winnings, the transaction is organized in such a way that by claiming the winnings, you also do the policing work. So the housekeeping for slashing the stakes that need to be slashed, and so on. So we have 3 phases: a commit phase where each participant commits, a reveal phase when again each participant reveals, and a claim payout phase when only the winner transacts. So this transaction is by far the most expensive, and the other transactions, the commit and the reveal transactions, are kept as cheap as possible in order not to discourage participation. So stakes can be topped up and they can be transferred between lottery rounds, but they cannot be withdrawn. So the safe strategy is to play honestly, because that if everybody else plays honestly, then that's when you are going to keep your stake and also keep your chances at winning the redistribution payout. And also it is organized in such a way that it's not worth operating sock puppet nodes, because if you have the one node with the joint stake of all those nodes, you will achieve the same result. So the problem with sock puppet nodes is that if you participate in the network with many addresses, pretending to be many nodes, but actually you are one, then you are undermining the redundancy of storage. And we want to disincentivize this kind of behavior, or not to reward it. And this is why we're having these stakes. That basically if you have 2 nodes or 1 node with the joint stake, then you have to work less with the 1 node and your chances at winning are the same. So thank you, that was all I wanted to say. So just to recap, the current update changed the fact that redistribution is possible. So from now on, everything that is paid into the postage stamp contract is subject for redistribution at some later time. And very soon we are starting the redistribution rounds, and somewhat later in phase 2 or 3, we're going to introduce the automatic price oracle when the rent is going to be adjusted automatically with supply and demand. So thank you so much. And so after everybody's talk, we are going to answer the questions together.
Thank you very much, Dani. It's amazing and very inspiring. Thank you. So, tying now all into this, Dani mentioned Wikipedia, mentioned as an example, I spoke about positive social impact. We mentioned also the great data upload, and what better way to start this kind of exploration, and the first step is with uploading Wikipedia onto Swarm. And to hear more about this, I would invite Costanza, who's leading the project, to tell us more.
Thank you. Thank you, Gregor. Okay, yeah, work. How does it work? Okay, so thank you so much for being here. And we're now going to see why it matters and why we're here. So let me first ask a question. How many of you have used Wikipedia in the past? Don't be shy, raise your hands. Okay, so you know why Wikipedia is important and why it matters. So, second question, what do people in China, France, the UK, and Venezuela have in common? You don't answer because you know the answer. Nobody? Okay. They all at some point had internet censored and couldn't access Wikipedia or parts of it. And that is why we're here today. We're here to protect freedom of information, which is the freedom to receive, seek, and impart information, regardless of borders and media. And when you think about it, it's not just those countries that ban Wikipedia, but so many more countries. You can actually find a Wikipedia article on Wikipedia censorships. Those are some of them, but not an exhaustive list. And if you think about it, it's pretty sad how many countries actually censor Wikipedia. So, wait. Yeah. So we're going to see 4 things. First of all, how Wikipedia gets censored. Then, what are some ways that today we can overcome the censorship? The Wikipedia Swarm Prize, so what Swarm is doing, and some long-term and bold plans. So how does Wikipedia get censored? There are 2 ways. And the first one is the human component, which we all became very knowledgeable of in the past month. So in the case of Wikipedia, for example, in 2013, the DCRI, the French equivalent of the CIA, that is swarm censorship. Yeah, I'm going to be far away. So in 2013, the French CIA summoned a Wikipedia volunteer and pressured him, threatened him into deleting a Wikipedia article. Now, he had no idea about the article. He didn't write it. He didn't edit it. He didn't even know about the existence of the article. Why they got him? Because he was famous enough within the Wikimedia circle. So it was a very easy target. So there's a plot twist, though, because censorship doesn't win. That was enforceable in France. Someone from very far away, from outside of France, from a very far away place like Switzerland, restated the article. So Wikipedia 1, censorship 0. And of course, if you read newspapers, there are way more recent examples of how threatening people for censoring Wikipedia is, unfortunately, a thing. And then there is the second component, the technical component. Back a few years ago, Wikipedia was running on unsecure protocol HTTP. So that means that censors could actually target illegal entries. So for example, they didn't like the entry of, I don't know, Rihanna, they could just censor it. So as of a few years ago, Wikipedia moved to HTTPS, which is more secure. And that means that today, if they want to censor Wikipedia, they have to either censor it all or not at all. So as a result, some of the countries dropped their bans. Some of the countries are banning the entire Wikipedia in one language, or just the whole Wikipedia. So this is as of today. And of course, there is a way to overcome that. One super clever way was developed by KWix. It's a Swiss nonprofit that lets you store Wikipedia offline. And the people working there are amazing. They've done some amazing things. And while that is a great solution, it has two problems. If you download Wikipedia on Swarm today, on KWix today, first of all, you need bandwidth, you need a good internet coverage, you need space on your laptop. So that is the first problem. But then, if you do it today, in 2 months, it's going to be outdated. And we know that information goes so fast, and everything happens so fast today. So this time, I didn't do anything. I'm just far away from it, so yeah. So that is not the ideal solution. So yeah, with Swarm, this is where Swarm comes into place. Imagine storing Wikipedia on Swarm. That will make it censorship-resistant, and that will mean that you don't need to re-download it every day to have Wikipedia. And for that, yeah. So as of today, Wikipedia, I can make it. So as of today, Wikipedia runs on 6 data centers between the US, Europe, and Singapore. Those data centers belong to private entities like Equinox or CyrusOne. Halas, in a very centralized fashion that makes it very easy to censor. So what if we could store it on Swarm? And that is why we had the Wikipedia Prize. Wikipedia Prize was a bounty, a 50K bounty, to 50K DAI, to develop a mirror copy of Wikipedia on Swarm. So the bounty deadline was a couple of weeks ago, and we received some very cool entries. So I actually want to do, not a demo, but I want to play a game with you. So here we have all the projects. I'm going to select one. Yeah, that one looks perfect. So from this project, we're going to test it live. So here's the link. You can access it without any B-node or anything. Actually, I don't know what this laptop belongs to. I don't even think that this laptop has a B-node. So I think that every one of you without a B-node can play this game. So we're going to check if the Wikipedia on Swarm works. And I need your help. So from this page, by clicking from link to link, we're going to go to the Ethereum page. Tonight is the merge, so I think it's a funny game to play. So I need a volunteer to tell me where to start. Sorry?
Computer science.
Something more difficult, come on. We want to test the Wikipedia. Music, OK. Something difficult, something not related to what we do. Music. But I need a laptop. OK, so music. OK, we have it. So from here, which hyperlink shall I go to? Sorry? Hold on, I'm giving the.
Second paragraph, fourth line of the
OK. Okay. I can see that.
Pythagoras should be into Ethereum.
Which one?
Pythagoras.
Okay. I see where you're going. I see how you're thinking. All right. Where do we go from here?
Back, and then computer science.
Latin? Latin is not an hyperlink, I'm sorry. Wait, second line.
The 7 liberal arts. Second line.
Okay. Okay, now I'm confused. Okay. Okay, that can be fun. Anybody? Mathematics, okay. I would have gone for logic, but hey. Mathematics. Okay, so from here. Come again? Which one? Cryptography. Crypto systems, is that good enough? It's everything. Cryptography, cool. We have it. Okay. Come again? I don't see it as big as you do from here, so I'm just. Okay. Woo! Now wait. What if it doesn't happen? He got it. Woo! So we can say that Wikipedia's swarm works. So this is one of the projects. We're still in the process of judging all the entries from the hackathon. So if you're working for Swarm and you receive my email, please. So where do we go from here? A little bit of a timeline. So the Wikipedia Swarm Prize is being judged as we speak, and the results are coming out in a few weeks. Then what's going to happen? Two things. First of all, and this is a very big dream of mine, so please let my imagination run wild. I would like in 5, 10, 15 years maybe, personal dream, speaking on my behalf, to not only to have an asynchronous version of Wikipedia running on Swarm, but to actually see the Wikimedia Foundation seeing the benefits and the potentialities of Web3, and to have not just this, but the entire production environment of Wikipedia on Swarm. And that would be super cool. Just imagine if Wikipedia was actually running on Swarm, was being stored on Swarm. Then there would be no absolute way of stopping it. And that's amazing. And to make that happen, there is the second component. So right now, the Swarm Association chipping 50K to make it happen. But Wikipedia Swarm cost. It's not free. It's not as expensive as the current hosting, but still, there are people to pay and hosting cost. And it can rely upon the funding from a single entity. So if we want to make Wikipedia truly decentralized and truly censorship-resistant, it has to be able to stand on its own legs. So that means that it's not just the Swarm Foundation, the Swarm Association, it's not just on us, but it has to be able to be independent in terms of governance and funding. So to make that happen, what I personally, again, would like to see is to work on the Wikipedia DAO so that the project becomes fully independent and can run on itself. So actually, if you're interested in talking about it, in contributing, just come to me. I'm very happy to discuss it. I think that's all for now. Thank you. So I guess this is time for questions for everyone.
Not just yet. We have also today in the audience, we have some builders on Swarm. Is Robert here? Yes, Robert, would you come up and tell us who's building on Swarm?
Okay, didn't expect this. Thanks. Yes, so if you've seen the demonstrations today, we got this weekend at EthBerlin at the hackathon. We got several teams also experimenting and building on Swarm. I know some of them are here. Please raise your hands. There's one over there. There's one over there. And I've spoken to 2 more who are not within my eyesight right now. But if you're interested, meet up with them over here and over there. Because yeah, there's enough to experiment. We'd love to meet every one of you. So that's it.
All right, thank you, Robert. So before I mentioned these nice flyers, the top-up codes for the Swarm desktop app, but we have also another kind of flyer. It's about the Swarm grants. And yeah, let's connect the dots. Now, I would ask all the presenters, Costanza, Dani, if you can join me. And one of the things, one of the reasons why also before I said I'm really happy to be here today is because I think the audience. Oh, we need to step more here, please. Just. You are skeptics and curious minds, and hit us with the questions, suggestions, anything. So we are opening now the AMA, and I see first hand raised. Just a second that the mic arrives.
Yeah, thank you. So first of all, yeah, thank you for the presentation. So I got 2 questions. So first is as long as I understand, get questions like for the incentivization layer. So it's the storage itself is basically still going to be off-chain, right? So you're only going to be storing hashes.
So, of course, storing the data on-chain is hopelessly expensive. So that's the whole point, that the data is stored off-chain, and there's a certain calculation that has to be performed on the data in order to prove on-chain that you're storing it.
Well, some protocols I think would argue that, but anyway, so if you're saying so that storage is going to be off-chain, and you're targeting like use cases like Wikipedia. Wikipedia is basically a use case that would require very long-term permanent storage probably. So basically, how would you target that? And second question is related. So I more or less understood like how you think the incentivization for storage would work, but how would you incentivize data retrieval actually?
So there's a separate incentive structure for bandwidth incentives. It's called SWAP, and it's been working for quite a while now, basically since the mainnet release, where if you are forwarding data, then you of course need to pay for bandwidth when you're retrieving it, and somebody is paying you when you are serving their retrieval request. But if you are caching it, or if you're just serving what you're supposed to be storing, then you're not paying for retrieval, but you're simply collecting payment for serving requests. Now, of course, here it's not true that in order to download something from Swarm you necessarily have to pay, because that kind of payment can be done in kind. So you can serve other people's requests in order to balance out your swap checkbooks with your peers. So data availability is incentivized by the fact that if you have some data and somebody requests it from you, then you earn some credit on these peer-to-peer relationships. And those who are only using the network and not contributing, they need to pay.
But you would still be relying on, sometimes they would be paid in kind, right?
Say again, please.
You're saying that sometimes the users would be relying on you like paid in kind, right?
Well, you can pay in kind. So if you, it's just like BitTorrent, that you can use your upstream bandwidth in order to balance out the downstream bandwidth usage. But you don't have to. So for example, if you're on a mobile, then you don't want to relay packets, or you don't want to upload other people's data, because it will, drain your battery and maybe your traffic charges if you're not on an unlimited plan.
Yeah, I've got a question. I think it's probably another one for Danny. It's about slashing, which is a bit of a scary word in the blockchain space. I'm just wondering if you could explain in a bit more detail, like what would need to happen for a Swarm node to get slashed? Like what's the, do you have an idea on what would trigger a slashing event?
Violating the protocol. So for example, if you commit to some calculations and then you don't reveal. So slashing doesn't mean that you lose all your stake at once. So it's part of your stake that gets slashed. But so protocol violations are slashable. And also if you are disagreeing with the majority about what that particular neighborhood should be storing.
What part is slashed?
Well, that's still being decided. So in the phase 2, it's going to be only stake freezing. We're not going to introduce slashing right away. So it's still to be decided what part is to be slashed. But we think about some small double-digit percentage.
My turn? Okay, so taking your example of Wikipedia, although I think this is an idea that would generalize across all types of useful data, I'm thinking particularly about Wikipedia and about the term astroturfing, when Wikipedia is flooded with bad information by a bad actor who perhaps has a lot of money. So I'm wondering, okay, it seems that it wouldn't be necessarily possible to take down the network and all of the information, but if somebody had a lot of money and an interest, they could flood it with bad information. That perhaps even bad information that would be so close that it could corrupt use of that information.
So Swarm is a content address network, content address storage, meaning that the address of the data certifies the validity of the content. So if somebody asks something from you, they can verify by themselves whether you're serving what has been asked for. And if there's a trusted source which is registered on chain, typically ENS, the Ethereum name service, is used for this purpose, then you look up what is Wikipedia, and then you request the data from that source. And because of the content address nature of Swarm, you can be certain that it's what has been uploaded. So it cannot be flooded with bad data. Maybe you also want to add something?
I actually have two questions. So
maybe just a second. So, in a way, I think basically the problem that you're mentioning, in a short way, it's a layer 2 problem from the Swarm's perspective. So it's and to address layer 2 problems, we should look at layer 2 solutions. This is in a way, to some extent, it links back also to what I said, how it's important also for us to try to steer the ecosystem in a right value-driven direction. But I would say one of the values, in a way, in the decentralized space is also the freedom to fork. So if one actor would basically flood the Wikipedia with bad data, the community can still fork. And I would say this is the value proposition of Swarm, that that the community is not forced to use any kind of version of Wikipedia, if we speak about Wikipedia. But like you said, this basically applies to all kinds of data, and we also see Wikipedia just as the first start. Did this maybe answer better? Yeah, sure. Yeah. So also maybe I wanted to add something where the question it was posed before about the strong connection with blockchain. I would say that Swarm, in terms of use cases, should also be regarded that it enables a spectrum of different use cases. And some of these use cases don't even necessarily need to use the blockchain. So just this, but happy to discuss this more. Any more questions?
yeah, I had two questions which are connected, and one would be for the first talk, and the second would be for the third, I guess. So first one, are there any plans to internalize the code of your client, node, whatever, into the browser? So it's like becomes apparent to store the entire websites on IPFS, on Swarm, basically on addressable storage. So did you think about that?
I would say the short answer is yes. Here somewhere is also Victor Todd. I don't know where Victor is. There, and he's the guy to speak to.
Right. Thanks. And the other would be, how do I calculate if I want to store amount of data on Swarm to make it zero-sum game? How do I calculate how much do I have to host, like in gigabytes, like in amount of?
So you look up the rent, and then you calculate like what amount of data you have for how long you want to pay for it. And of course the prices might change, so it will be only an estimate, but you can estimate how much you need to pay for a certain period of time. And we expect that it will be roughly in the same ballpark as cloud storage, because many of the Swarm nodes are hosted with a cloud provider, and they will need to cover their running costs.
Yeah, basically the question is if it would be deterministic or not. Or it might depend on the frequency of access to my data, which I store.
No, it doesn't depend on the frequency of access.
Right.
It only depends on the duration and the amount of data.
Hi, thanks. I wonder, what's your opinion, what's your point of view on being like more like pops-up network when you update data frequently, some amount of data for a short period of time, but really frequently? Do you plan to disincentivize it somehow, or do you, like, you don't care about it?
So I would say Swarm feeds are tackling this question, no, Dani? So essentially Swarm feeds, with Swarm feeds you can link it to an ENS name, but the content can be dynamically changed. So there is no need for constant blockchain updates. But I'm not sure if this was exactly the question. It is, in a way, we've been told quite often that the feeds are sort of like one of the killer features of Swarm, because they enable dynamic website or any kinds of dynamic content on Swarm. Awesome. And
yeah, okay, so maybe this is a bit naive question, but generally, let's say, hacker leaks, hacks the database with a lot of private information, I don't know, card numbers, PIN codes, whatever, publishes it on Swarm, right? And I'm just interested, in like how you kind of just mitigate the whole idea of people, like storing like good data and bad data. You know what I mean? Essentially, like if there's just a lot of bad usage of Swarm, for things that people don't want to expose a lot. And there's, let's say, 70% of like things that people don't want to be there, and the rest is Wikipedia.
Yes, that's a very good question. That's it's at the end of the day, we need to recognize that we don't have control. So Swarm is an open source project. It's we cannot control who uses it and for what's being used. It can be also just cloned, and a new Swarm can be triggered. It's At the same time, we don't see that we are enabling new use cases in this sense. So it's kind of, to me personally, it comes a little bit to this discussion that we see like a frequent debate about cryptocurrencies, that they enable bad things, but then we look at the information about money laundering in dollars, and it pales in comparison with cryptocurrencies. So cryptocurrencies are not the enabler for bad behavior in that sense. Or when it comes to discussions about cryptography, it's kind of the same thing. So we do see that what we have, what is in our way, field of possibilities, are basically using positive incentives for the ecosystem. So it's where do we draw the attention of the ecosystem? What can we support? How can we also think about the design of the systems so that they hopefully drive in the desired direction? But yeah, at the end of the day, this is in a way, like an eternal question since the invention of fire. As with fire, you can prepare a dinner or burn down the village. And it's yeah, it's a difficult question, and definitely something that does need to keep ourselves on the toes. This is exactly what I meant before with that one of our goals is the positive social impact. Personally, I think this is something where we should never stop resting and look into how it can be improved.
Can nodes be incentivized to reject obviously malicious information?
Obviously, who decides what's obviously malicious? Who do you trust? Right now it's AWS and state.
So mostly nodes don't know what they're storing. So as I mentioned in my talk, all the information in Swarm is broken up into really tiny pieces. The vast majority of that is encrypted, and who gets to store what is decided upon the hash of that little piece of information. So a node doesn't know what it's storing. It's not storing anything in its entirety. So it's not like they're storing files. They're storing these little chunks, and they are encrypted, and one chunk looks like another. So really, it's not, the nodes don't really get to decide what they store.
Thank you, Dani. Maybe, yeah, just for illustrative purposes also, it's kind of like when we look at the TCP IP, it's just dealing with packets. And when we look at HTTP, this is where we see web apps happening. And one could say, like, when we speak about data management, for example, GDPR. So this does not belong onto layer 1. GDPR is basically tackled, and regulation and all this is tackled on layer 2. And in a way, sometimes in these discussions, what I use more as a conversation starter is think of farmer's market. So there are like all kinds of these ingredients. The more it's decentralized, the better. One can go buy all the ingredients there and create the most awful lunch in the privacy of their own home. And we also have restaurants buying on these farmers markets. And these restaurants, they're opinionated. So a pizza place is opinionated through its menu, a vegan place is opinionated through its menu, and so on. Now, today, what we have the problem is actually that we only have restaurants. We don't have the farmer's market. So we are kind of forced to go into these restaurants without basically the personal freedom to do our own, to prepare figuratively our own meal. And this kind of ties into also the question that before we had like with Wikipedia, and I said like layer 2 solutions. So it's difficult, you know, like we see the constant challenges we see with moderation in social media, etc., and the dark web is not going to go away, and all these things. So it's at the end of the day, it more even depends like how we decide what kind of services we use, and if we go to a restaurant or not. In that sense, yeah. Yes.
I think I can suggest a solution for you. So
please do.
Obviously, there is such a fact as the wrong data, and for instance, in the same Wikipedia, there could be some like wrong facts, right? And someone could exactly working for that and making them not true, and someone will want to change the facts to them being true. Of course, that would require some, vote and some truth to be resolved and put into place. Of course, that would also require some voting for and over for this truth to become the fact and become posted on the website, right? And that leads us to some trusted community or democracy. And let's say, I'm talking about on-chain democracy and on-chain governance. Did you think about that?
Yes and no. So, and what I mean with this is, I think it would be great if you do it. So it's essentially what I also mentioned before, that Swarm enables this kind of innovation on top of it. And this is, you just came up with one of these examples. And this is why we also need to work on this together. From Swarm's perspective, it's outside of its immediate scope. We need to make sure that the ones and zeros are stored where they are supposed to be, and that they are delivered to the person that needs to get them. But yes, it's. I do invite you. Do it, and we try. Awesome.
I have a working solution, but I think not in this scope of this presentation. That would be a little bit advertising.
Let's talk.
Sure.
I don't know if Dani or wants to add something.
Well, as it was mentioned in Gregor's presentation, Swarm makes it really easy to fork large data sets. So take a large data set and change a little detail, and then present it as something different. And humanity tends to cluster around a few opinions about everything. So there's no contentious question about there are hundreds or thousands of different opinions. Usually there's a handful of opinions about everything. And it's a matter of a user interface to present to Swarm user that on this particular topic, there are these 5 opinions that are held by different people. And then there's a second layer, which can be something that you provide something with voting or something with delegated trust or something like, I don't know. So there are many ways by which you can select like your flavor of trusted truth.
Indeed, yeah, thanks.
So here maybe, yeah, here we're already going maybe also in a more freestyle kind of thing. Personally, what, for example, also excites me are knowledge graphs on Swarm. And I would say that exactly this, what we need is more traceable data. Where does it come from? What are the origins? And you know, if you look at number 6, if I look at it on the floor, can be number 9 for you who are looking from the other direction. So we can see these knowledge graphs diverge and then again, you know, converge on some universal truths. And here we basically, we can go like back to the times of Socrates. It's like, it's such an old problem, and kinda, in a way, the space that it's the most discussed, it's what Socrates would say, the double ignorance space. So, and traceability of data, having the references to back to know where something came from, I would say this is something that excites me to see in the future, for example.
I mean, we've seen the use cases from the different sites. So if you recall the parity bug that could have been reverted, but it's blockchain. We can't revert stuff on blockchain. But then someone came up with the idea that the stuff on the blockchain can be reverted if everyone is okay with that, right? So that kind of, if everyone is okay with rewriting the blockchain, then let's do it. Why not?
Yes, good point.
Yes. Thank you for all the presentation. Just one question around what you call the price oracle. Can you describe more? Or like, is it not a market that decides the price, or just I wanted to know more about it.
So it's so Swarm is not a marketplace for storing data, so you don't get to choose what you're storing and what you're not storing. And because of that, so this price oracle is actually a market mechanism, you can say, because it follows supply and demand, but there's no order book, because or no auction or none of the traditional market mechanisms, because it's not really a like we try to commoditize it, but it's not a commodity. Like, it's not, you cannot, I mean, storage is a commodity, but the data itself is not. So in order to for Swarm to be content agnostic, we decided to go on a route where the price of storing a piece of data is uniform across the network, but there's a mechanism which increases and decreases the prices with demand and supply.
Okay, thank you.
Okay, one tiny last question for me. With the commit and reveal scheme, yeah? So because you say that the node that accepts the data that it stores, yeah, it's a hash of a tiny chunk, right? So when it commits, what does it commit to a hash? And when it reveals it, what does it exactly reveal? So I'm kind of just missing this little bit.
So they reveal a proof that they are storing what they're supposed to store. And what they're supposed to store is decided by the shelling game, that the number of players that are supposed to store the same information, they perform this calculation. Or are you, if you're interested in the minute details of how its calculation is performed, we can talk about that. I think it's an implementation detail, but essentially it's a random sample of the data and then a proof that they're storing that random sample. And that random sample can only be the same if what they store deviates very little from everybody else who stores the same.
Other questions? So I think we're done.
I mean, we got time, so then there's like, ask away, you know, if there's anything. But if not, let's, yes?
I have a question. When is pizza coming?
Oh, pizza is already there. Here, yes. There, there. Okay, yeah. All right, thank you, everybody. Also kind of just gets out more, so yeah.